Okay, so we're going to start, what we do the rest of the time now in chapter 8 is we actually solve quadratic equations. So now we know stuff about quadratic functions, we should know enough about them, that now we can tie in solving them. So when we solve quadratic functions, what we're actually finding are the zeros of the function. What are zeros again? Where it crosses the x-axis, the x values of the x-intercepts then basically, right? Okay, so what did we learn? There can be how many zeros? We learned there can be 2, 1, or none. Well, that relates to how many solutions there are then. If there are 2 zeros, there will be 2 what we call real solutions, because there is such a thing as imaginary solutions also. But we're going to strive for the real ones. If there's 1 zero, how many solutions do you suppose there are?
1.
Just 1. And if there are no zeros?
No.
It's going to be a no real solution problem. Now again, no real solutions. There would be imaginary solutions though, okay? So today in your homework, you will always get one of the top 2. We won't have any no solution ones. So hear that right now, loud and clear. You are not going to say, I could not factor this, so there are no solutions. I'm telling you that all the ones in your homework can be solved. They will either have 1 real solution or 2 real solutions, okay? So for every quadratic equation has a related quadratic equation of ax squared plus bx plus c, but instead of setting it equal to y, we set it equal to 0, because remember, the zeros of the function are the x-intercepts of the function, and what's true for the x-intercepts and their y values? What are they?
0.
They're 0. So we can replace the y with the 0 because we're really looking for which x values will make the y value equal 0. So that's why we set it equal to 0 instead of y when we want to solve it. So we're going to apply the zero product property, which says if at least one factor, so you're multiplying product, if at least one factor is equal to 0, what will the product be?
0.
I don't care if there's a million factors in a multiplication problem. If only one of them is 0, the product will be 0. So that property will help us solve these, because we are going to use the factoring method. That's the first method we're going to learn, is how to solve by factoring. Now, not all quadratic equations can be solved by factoring, because first of all, the quadratic we are given has to be factorable. If we can't factor it, then we're going to have to use another method to solve. Today, when we're learning the factoring method, they are all the ones we're going to do are going to be factorable, okay? So we're going to use setting the equation equal to 0. So we're going to replace the y with 0. We're going to factor the other side of the equation, the quadratic function rule, ax squared plus bx plus c, to rename it. In other words, just give it its factor name, because then we can use the zero product property with those factors to find, let's just, is that what I want? There is, yep, to find solutions. Solution or solutions. There might only be one solution, not 2. One or the other today. Okay, so here's our first one that we're going to solve by factoring. X squared plus 4x minus 21 equals 0. So it's already set equal to 0. We don't have to do that part, do we? Okay, when we solve trinomials, this is the part that we are going to, or when we rename trinomials, here's our trinomial that we're going to be factoring. We use the diamond method, right? So A is 1, B is 4, C is negative 21. Love when A is 1, it's a lot easier. What multiplies to negative 21 adds up to 4?
7 and negative 3.
7 and negative 3. So that means the factored name for this trinomial is what? What's its factored name then?
X plus 7,
X plus 7, x minus 3. But remember, that's renaming the trinomial part. It is still set equal to 0. So we still have an equation. It's just that we renamed the trinomial. And now, if either of those factors would equal 0, what would the product be? 0. So we're going to set each factor equal to 0 and solve for x. So we'll say x plus 7. What would make that factor equal 0? What would this one be? Negative 7. So that is one of our zeros. And our other factor is x minus 3. We set that one equal to 0 because what would make that one equal 0? It is positive 3. These are our solutions. Okay, go grab yourself a graphing calculator, please. Quickly. We have a couple of different ways we can check to see if we have good solutions. We can use a graph, or we can check them algebraically. In your homework, it's going to tell you to check your answer, but today I'm not going to make you do that. I want your focus to be on solving, and hopefully you're going to have the right answers. So, what I want you to do is go to your y equals, and I want you to put in, if there's anything in y equals, clear it out right now, and I want you to put our trinomial x squared plus 4x minus 21. So press the x key and then the x squared key, it'll square your x. Plus 4, use the x key again. Minus, use subtraction, 21. So put the x right there. And then square it. Okay, now plus 4x. Okay, now do a zoom 6. Do a zoom 6. And where should this, first of all, this parabola should be opening what way? Up, is it?
Yes.
Okay. And then it should be crossing the x-axis where?
Negative 7.
Negative 7 and 3. Does it appear to be crossing at negative 7 and 3?
Yeah.
So one of them is on the negative side of the x-axis and the other one's on the positive. Okay, let's go to the table and check. Second graph takes you to the table and look for the x values where the y's are equal to 0. Well, we already go find negative 7.
Negative 7.
Is negative 7, is y equal to 0?
Yeah.
Okay. And at 3 is y equal to 0?
Yeah.
Do you think there's any other places in there?
No.
Because I'm guessing the vertex is in the middle of those two, right? I bet right now you can tell me what the vertex, at least what its x value is. What's the x value of the vertex? Remember, the axis of symmetry, which has the vertex on it, is halfway between the zeros.
Could be negative 2.
Negative 2, yeah. So look in the table. Does it, once you get it to negative 2, it kind of have negative 2. Yeah, it's good. We're down there a ways, isn't it? Can you see the symmetry in the table around that vertex?
Yeah.
Okay. Turn those off for a minute. Let's go solve another one. Okay, backside of the first sheet. Solve x squared minus 4x, or plus 4x, excuse me again, but minus 5 this time. It is already set equal to 0, so we can go right to saying a equals 1, b equals 4, c equals negative 5. Again, a is 1, those are the nice ones. Not so much work. What two numbers?
5 and negative 1.
5 and negative 1. Okay, so that means its new name is what?
X plus 5 and x minus 1.
X plus 5 and x minus 1 equals 0. set each factor equal to 0, because if only one of the factors equals 0, it makes the product 0. But we have two factors, so we have to set each of them equal to 0. So we're learning something new today, but do you have all these skills already? Yeah. You already have all the skills to set you up for being able to solve quadratic equations by factoring. That's why I said factoring was so important back in chapter 7. Okay, check it out with the graphic calculator. Go clear out the one you had in there, put in this new one. Basically, I think all you're going to change is the -5. 21 to -5, right? It was a lot like that last one. Check the table, because in the table, when x is -5, it should have a y value of 0, or we're wrong. Does it?
Yep.
Okay. And that one checks then. How about the other one? When x is 1, y should be 0. Is that one in the table?
Yep.
Okay. When you look at the graph, does it appear that this is where the parabola is crossing?
Oh,
So solutions, I want you to start making that connection. When you are solving a quadratic equation, you're basically finding the x-intercepts, or you're finding the zeros, or you're finding where it crosses the x-axis, or, you know. So which ones would have no solutions then?
The ones that don't cross.
The ones that don't cross, yeah. Which ones would have one solution then?
The vertex is on the x-axis.
When the vertex is on the x-axis. Remember, that's when there's only 1, 0. Okay, questions so far? Okay, let's try one more where a is equal to 0, or not 0, where a is equal to 1. But is this one set equal to 0? No. So what should we do? Okay, add 9 to both sides, so get that 9 over there with it. So when it moves to the other side, it becomes a positive 9?
Yeah.
Okay. Now let's identify our A, B, and C. And what are our two numbers there?
-3.
-3 and -3, okay. So then that makes our new name
X minus 3 squared.
x minus 3 squared, which is also the same as x minus 3 times x minus 3, right?
Yep.
Okay, well, here's the deal. When you have one factor times itself, how many solutions do you think there's going to be? Just one. This is really the same factor twice. So when you have the same factor twice, you only have one of them to set equal to 0, really, because you get the same thing both times. So we would get our solution to be x equals 3. You could go ahead and do this one, but the other factor, but again, like I said, what's going to happen? We're just going to get the same thing. Can that parabola cross the x-axis twice at 3?
No.
No. So we have just found the x value of our vertex, haven't we? Put this one in, check us out, see what it looks like. It better be sitting on the x-axis at 3, 0.
Yep.
Check it out, come on, everybody participate. You're going to need to know how to use these graphic calculators next year and the year after. It does sit on the x-axis there?
Yeah.
Okay, and so what should happen in the table also then? What should be true in the table?
It should be equal to 0.
Where x is 3, y should be 0, and we should be able to use that point to see our symmetry too, right? So what's the domain of this one? Domain.
All
All real numbers. Quadratic functions, unless we know what they're restricted to, it's all real numbers. What's the range?
y is greater than or equal to 0.
Y is greater than or equal to 0. In other words, there will not be any negative y values over there. Okay. Questions on the easy ones? I call these the easy ones. Okay, let's go on to the ones where A is not 1. Okay, when A is not 1, we still kind of have the same, strategy. Get the equation set equal to 0. Factor to rename it. But here's the one step that's going to take a little more pain, is factoring it and use the product property to solve. So our first one is negative 3x squared equals negative 4x plus 1. I always suggest having a positive a value. So what should we should move our x squareds
Add
over?
3x squared.
Yeah, so it's going to become a positive 3x squared on the other side. Does it matter which side 0 is on? You suppose? No, doesn't matter. Okay, A equals 3, B is negative 4, C is 1. What do we have to do when A is not 1?
You have to multiply A times C.
You're going to multiply the A times the C. Well, in this case, we still are multiplying by 1, but not always is that the case. So our product has to be 3, and our sum has to be negative 4. Negative 3, negative 1. Okay. Well, remember, when A is not 1, this does not mean our factors are x minus 3 times x minus 1. That would be x squared minus 4x plus 3. And that's not what we're factoring here. So these actually become, remember, they become x's. Negative 3x plus negative 1x. And they take the place of this negative 4x. So we are going to rename right now, we're just going to rename our trinomial as a 4-term polynomial. Replacing the negative 4x, and now we're going to factor by grouping. All stuff we did back in chapter 7. What's the GCF of the first group?
3x.
3x. What's the resulting factor?
X minus 1.
X minus 1. Okay. Bring down the addition sign between the groups because they're still groups right now. What's the GCF of the next group? 1 or negative 1?
Negative 1.
We need it to be a negative 1 because we need this to be a positive x, don't we, to match. So negative 1. So now we will end up with x subtract 1. 1 divided by negative 1 is a negative 1, isn't it? Okay. That means we have the factor they have in common, x minus 1. Now we get rid of the addition sign between because we're bringing the factors together. What's our other factor?
X minus 1.
No?
Or 3x.
3x plus a negative 1, which is 3x minus 1, right? Everybody keeping up? This was what we learned a while ago. Renamed equation, 0 equals x minus 1 times 3x minus 1. Now we still use our 0 product property, saying what would make each of those factors equal 0. So x minus 1 set equal to 0. What's one of our solutions?
X equals
Okay, there's one of them. We set the other factor equal to 0. Gonna have to work a little harder solving this one. It's a 2-stepper. Is 1/3 a nice decimal? No, so we're going to leave it as 1/3. We're not going to make it 0.3 repeating. So we have 2 solutions. 2 places it should cross the x-axis. We won't put this in an air graphing calculator, so we have to change the what the x-axis was going by and everything to make it show it, so we'll just trust that we're right. How could we check it though if we didn't use the graph to check it? We can plug it in, we could do this, plug it into, take both of these separately, put them back into the original equation, you would check it right here in the original, remember? But we'll not take the time because we need to keep moving, because checking 1/3 is not gonna be fun. Okay, let's go to our last one. Because I do want you to have some time to work. We are gonna check this one algebraically though, because it's a nicer one. Okay, negative 2x squared equals 18 minus 12x. What do you suggest we do?
Add 2x.
Add 2x squared to both sides? Okay. Because then it'll be a positive a, and that's usually nicer. So we're going to have a 0 like we need. We'll start with the 2x squared. We'll subtract the 12x. We'll add the 18. Okay. Anything staring anybody in the face here?
It's divisible by 2.
Oh, it's divisible by 2. Now, when it's divisible by 2, do you think it might be worth GCFing that out first? Yeah, because then you're going to create an A value that is 1, aren't you? You're going to make your life easier. So remember how when we learned how to factor completely, we said, oh, if you can factor out a GCF, do it. So let's do that. We're going to have 0 equals 2 times x squared minus what? 6x plus 9. Oh, is there anything else staring you in the face there about that x squared minus 6x plus 9? They both, it begins and ends with a perfect square.
Special problem.
It's a special product, maybe. What does it have to have in front of the c value? Addition or subtraction?
Addition.
No,
Addition.
addition in the trinomial special product. This has to be a addition right here. And then what's the one last test we have to do?
Subtraction.
No, the square root of the first term times the square root of the last term. Doubled is, would it be 6x?
Yeah.
Okay, and then what would each factor have in it? Subtraction or adding. Remember the middle term is subtraction, it's negative, so that means that it would be a binomial times itself with subtraction in it. So, boy, using that special products, maybe if that doesn't work for you, you can still do this. You need 9 and this, and guess what you're going to get? So this is 2 times x minus 3 times x minus 3. Well, there's 3 factors. Does that mean we have 3 solutions then?
No.
No, because does the first factor, that 2, have an x involved in it? No. If it had an x involved in it, yeah, but it doesn't have an x involved in it. And it won't, we'll never have 3 anyway. But, so we get to disregard that 2, and we say, okay, I'm going to set x minus 3 equal to 0, and I only got to do it once because it's the same thing. And x equals 3 is the only solution for this one. So we're going to check this one both algebraically and with graphing calculator. So throw it in the graphing calculator first. And by the way, when we use the graphing calculator, we have to check it using, after we've got the trinomial all on one side. So 2x squared minus 12x plus 18. Check that. Put that one in. What happened? Is the vertex sitting on the x-axis?
Yeah.
At 3, 0, okay. And in the table, where x is equal to 3, is y equal to 0? Okay, I'm kind of curious, the last one had this same solution. right? So does that mean they are the same parabola? What do you think? What?
No,
No? Why not?
because one of them kept the vertex on the x-axis.
I thought they both did have the vertex on the x-axis at 3, 0. So go to your y equals, and in y sub 2, do not take this one out. In y sub 2, I would like you to put back in the function that we had for, oh, not this last one, there was one though. Okay, it must be back another one.
Number 3.
Number 3 on the first page, on when a was equal to 1. That's the one that had the same solution. When you put in y sub 2, will you put the x squared minus 6x plus 9?
It's
Okay,
because
guys,
that's a
you do this.
simplified
Are
version.
you having way too much fun?
It's because that's
They're
the
the same.
simplified version when you took the GCF out. So they're the same.
So, but they're the same in the fact that
But they're not the same because of the G.
is one, are they exactly on top of each other?
No.
No. So which one is which? Can you tell?
Yeah.
Which one is? Is one skinnier than the other?
Yeah.
Okay, which one is the skinnier one?
The last one we just did.
Yeah, last one we just
The one where we
did.
took the GCF out.
So the one that had a 2x squared plus whatever it was, right? Okay, so it appears that when a, what else is the a value doing besides making it open up? What else is it doing?
Figure it out.
How wide it's going to be, isn't it? It's also got to roll like that, which is going to be important in coming math classes also, that you understand how the a also transforms it, what it also does to it, okay? So now I want us to check this algebraically, okay? So let's go back to that back side where we were. And when you check it algebraically, you have to, so I want you to put in your notes that that's what we're doing here. Again, in your homework, I'm not going to make you do this, but you can, and I want you to be, you have another checkup quiz coming up on solving quadratic functions after we learn all the solving methods. I want you to be able to check algebraically, because I'm not going to let you use graphing calculators for those. So negative 2x squared, we do it exactly in the one it started in. Negative 2x squared equals 18, is it minus 2x? Minus 12x, okay. So we're going to put 3 in both places where our x is. And let's try not to use our calculators to do this. I think we can do it without. Negative 2 times 9. 18 minus what?
36.
36. What's negative 2 times 9? Negative 18. What's 18 take away 36? Just so happens to be negative 18 also. It checks. So I want you to be able to check your solution or solutions algebraically also. If there were 2 solutions, would there be 2 check problems?
Yes.
Yes, they each need their own check problems.
So if you don't do it into the
Original?
yeah, then it would probably be wrong.
No, what will happen is if you do it in the original, or don't do it in the original, and you do it in something else along the way, it's going to check, it's going to be like a false positive. It's going to fool you, and you're going to think you have the right answer because it checks, but it's because you're checking it in your incorrect work. So that's why we always go back to the very beginning and check it there, because we could have made a mistake when we were renaming it. Does that make sense? Okay. Okay, let's get you started on your homework then.
Maybe.